Hi, today we're going to talk again about slope as the rate of change, but this time a little bit more on equations and then patterns and pictures. So from equations, the slope is the constant rate of change. It's always the coefficient of the input x. So in problem number 1, this equation relates to the amount of money Karen saves each week. So Karen's going to save $10 per week plus the 75. The 75 is the initial amount she has in there. So let's just kind of take a look at the table. Um, you see that the W has weeks 0 through 4, and then they want us to calculate how much money Karen actually saves each week. So if she has 0 weeks, you would put a 0 in place of W. So 10 times 0, 0, 0 plus 75 is 75. And then the 1 goes in place of the W for the first week. So 10 times 1 is 10, plus 75 is 85. And then you put the 2 in place of the W. 10 times 2 is 20. 20 plus 75 is 95. But you see, it's just going to go up. As long as the W goes up by 1s, the savings will go up by 10. So this will be 105. And then this will be 115. So let's go see what the questions are asking us. It says, what is the rate at which Karen is saving money each week? $10. What is the y-intercept? So the y-intercept is that number that's by itself. That's 75. And what does that mean? That's her initial amount. Some babysitting money or something like that. 1C, how much money would she have in the bank after 12 weeks? So you would put 12 in place of the W. So 10 times 12 is 120. So let's see, that would be 120 and 75. So that would be 195. All right, 1D, how many weeks would it take her to save 375? Well, if I put 375 in place of S, that's like a two-step equation. So you take 375 minus 75 is 300. 300 divided by 10 would be 30. So take her 30 weeks. What would be a new equation if she adds 3 times as much money to her account each week? So instead of 10W, it's just going to be 30W. So S equals 30W plus 75. All right, let's look at 2A. It says that your parents bought you a meal ticket for college with $300 on it. Each meal you buy costs $6. Which of the following equations models the amount of money A on the card after you have purchased N number of meals? So we know there's going to be some subtraction going on here. So it's not going to be letter F, and that's it. So you're subtracting $6 per meal. So this one shows subtracting 300. That's your starting amount. And this one shows $300 per number of meals minus $6. So that one really doesn't even make sense. So it is going to be letter G because you do start with 300. That's positive 300. And then the negative 6 in. That's like minus $6 for each number of meals. So it is going to be letter G. It says use your equation from 3A. It's actually not 3A, it's 2A. To find out how many meals you have purchased when you have $180 left on the ticket. So again, this is another two-step equation, just like it was up on problem 1. You would subtract 180 from 300, which is 120, and then 120 divided by 6. So that would be, how many meals have you purchased? That'd be 20 meals. All right, now let's go on into the patterns. So we have patterns here. It says when given a pattern, make a t-chart like the one to the right. Find the nth term. So on number 3, it says which of the following expressions could be used to find the perimeter of the nth set. Okay, so that means a set on down the line, like the 15th set or something like that. So what we're going to do here is we're going to set up a t-chart. So our n, so this is our n, it's going to represent our sets. And we have 1, 2, and 3. And then the other one is going to represent our perimeter. So remember, perimeter is this all the sides on the outside. So in set 1, we have 1, 2, 3, 4, and then 2 ends, which makes 6. On set 2, we have 1, 2, 3, 4, and another 4, which makes 8, 9, and 10. And then 3, we have 1, 2, 3, 4, 5, 6, and 6 makes 12, 13, and 14. Now, what you're going to do is you're going to take the number from the first column, which would be the n column, and you're going to plug it in place of n right here. So we're going to take, I'm just going to start with 1. We're going to start right here. So we're going to put it right there. So 1 plus 4, does that give us 6? No. Then we're going to put it right there. 4 times 1 is 4 plus 2 is 6. That's good. 4 times 2, we're going to start with the 2 then. 4 times 2 is 8. 8 plus 2 is 10. That's good. And then 4 times 3 is 12 plus 2. Bingo. It's going to be that one. All right, let's look at problem 4. It says the tower currently has 4 levels. If the pattern continued, which of these expressions could find the number of total blocks needed for any level? Count the levels from top to bottom. So again, we're going to form a T-chart, and our N column right here, this is going to be our levels. And then this is going to be the number of our blocks. It's not perimeter anymore, it's the number of blocks. So we've got, and it says count the levels from top down. So 1, 2, 3, 4. So we've got 1 block on the first level. We've got 1, 2, 3. Second level, we've got 1, 2, 3, 4, 5 on the third level. And we've got 1, 2, 3, 4, 5, 6, 7 on the fourth level. So now we're going to do the same thing. We're going to take these numbers and let's just start right here. So 2 times 1 is 2 plus 4 is 6. Let's try over here. 1 squared is 1, yes. 2 squared is 4, not 3. Let's try right here. 3 times 1 is 3, minus 2 is 1. Good. 3 times 2 is 6, minus 2. All right. So now we're going to try right there. 2 times 1 is 2, minus 1. 2 minus 1 is 1. 2 times 2 is 4. 4 minus 1 is 3. 2 times 3 is 6. Minus 1 is 5. And 2 times 4 is 8. Minus 1 is 7. So bingo. That is the one that we want. All right, let's see what we have over here on this back side. Now it's from pictures. So with pictures, like a ramp or right triangle, the slope is a ratio of vertical change to horizontal change. Always reduce and never use the slanted height. So no and no, and we don't need that degree in there. So it'll be your rise over run. So that's what that one is. Didn't have to reduce or anything. Over here, we've got 134 divided by 500. And I know that this will be divisible by 2. So that is 67 and 250. So we're going to go with that. All right.